Neuroscience. So neuroscience, again, unit 2, biological basis of behavior, also deals with your ideas of your neurotransmission, or how your neurons communicate with each other. And also, there's also the idea of, how how your body, or your body's communication systems here. So here I've got a question here, or so you have a question here. Okay, 58, the neurotransmitters. I gave you, or rather you saw a list of neurotransmitters that you're going to have to know. So in the vocabulary list that I had given you on yesterday, or in the vocab list, I think it's chapter 2. Inside of chapter 2, it's a lot of words, but inside of those words, there's a list of neurotransmitters that you absolutely have to know. Okay, absolutely have to know. Of these, anandamide is not one of them. So we're going to get rid of this one. You have to know dopamine. You have to know ACH, or acetylcholine, ACH. Sometimes it's like, I think it's ACH like that. Or is it ACH? Yes, this is ACH like this. And serotonin. You have to know these 4 at the very least. At the very least, okay? Dopamine is critical to movement, okay? Dopamine is critical to movement. People who have low levels of dopamine here, you're going to see Parkinson's disease. If you don't know what Parkinson's disease is a degenerative disease in which people start to get these shakes or tremors because they can no longer control their fine motor movements. Serotonin is linked to your mood and your mood levels. And so people who suffer from depression, they have, again, wonky levels, or the levels of serotonin are low, or there's not very good. Okay. And then ACH is an excitatory neurotransmitter, which helps you with movement, with memory and stuff. And then finally, we have GABA. GABA is what we call an inhibitory. Yeah, that's how I spell it. Inhibitory neurotransmitter. And what that means is it basically blocks, right? It will shut down certain things here. The whole point of GABA is, obviously, your brain or your body will activate itself in some cases here. But if your body continuously only is capable of activating itself, it can never slow itself down. And so in these cases, this is why we need to have certain neurotransmitters or certain hormones which calm us down from our excited or aroused states. GABA is one of those things. Alcohol, a drug, okay, and again, we'll talk about drugs today. Alcohol as a drug has a very similar effect as GABA does, all right? And this is why it's very dangerous when you drink excess amounts of alcohol, because it shuts your body down. Right? It sounds weird to say that because, when people drink, you think about parties and people are having fun at these parties. Yes, but no. In actuality, alcohol shuts down your neurons. It shuts down some of your functions, okay? For example, the human eye cannot see a fastball that's going 96 miles an hour. The human eye simply cannot see that amount of movement, that speed of movement. And so unconsciously, the brain is doing all of that calculations in its head and thinking, all right, the ball started here. The pitcher is throwing the fastball, so it's going to go straight. It will probably come to me. And all of that is it's all taken care of unconsciously here. Okay. So it's kind of interesting. It's very, very fascinating. Okay. So some things we see with this dual track mind, we see something called blind sight. We have something called selective attention and selective inattention for this reason. Okay. Blind sight here. It's kind of cool. So this woman, she has brain damage, but she has no eye damage. Finally, choice blindness here, okay? Choice blindness, in this one here, we don't actually realize, okay? Maybe this is like a change blindness type of thing here. In the experiment, people are told to taste 2 different jams, all right? So we have a jam in a white jar and a jam in a dark colored jar here. So then here, what happens is the jar, okay, the jam is switched so that the jam that's in this jar is put in the jam in this jar.